Phy, purple phy, phy, purple phy. Physics. Welcome!
Welcome to our first AP Physics Camp video. Today we're going to be reviewing the AP Summer Assignment. Hope you guys enjoy and don't forget to study. Let's start with section 1, determining the number of significant figures. Now, it's important for you to be familiar with all 4 of these rules. The first rule states that you should consider all non-zero digits to be significant. So for instance, number 1, there is blank significant figures in 23.83 meters per second because there is blank non-zero digits as described in what rules. So first off, we are going to consider all non-zero digits to be significant. So as we see with this number, there is 1, 2, 3, 4. 4 non-zero digits. So that means 4 non-zero digits as described in what rule? Well, that was rule number 1. So that means that there is a total of 4 significant figures in that value. Okay, so rule number 2, consider all the digits found in between non-zero digits to be significant. So if you have non-zero digits, then that means that any of the numbers that are in between those non-zero digits are going to be considered significant. Doesn't matter if they are actually zeros. So for instance, they're giving us this value here. Well, we know this is non-zero, 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 non-zero. Well, this is my non-zero, and here's another one. So that means that all of the digits in between these are going to be significant. So that would be a total of 1, 2, 3, 4, 5, 6. 6 significant figures, because there is how many non-zero digits here? Well, there is 1, 2, 3, 4, 5. There is 5 of them. And how many digits are in between those non-zero digits that we didn't already count? Well, there was one of them right here that's 0. So that means 5 plus that 1, that gives me the total of 6. Now, this is described in rule number 2, as we just mentioned. Rule number 3, consider all the zeros to the left of significant digits to be non-significant. So if we have certain significant figures that we already know, and we look at those, and any zeros that are found on the left-hand side of those are going to be non-significant. So for instance, they give us an example here. We know that these are significant figures because of rule number 1, and that is stating that the non-zero digits are going to be significant. Well, I already know that I have 2 of those. So there is 2 non-zero digits. Now, all of these others that are to the left of those non-zero digits, those are going to be actually considered non-significant. So those zeros are going to be considered non-significant. Now, look at what it's asking though. It's saying there is blank significant figures because there is 2 non-zero digits and blank zeros to the right of the non-zero digits as described in this rule. So they're not talking about these zeros. They're talking about any zeros that are to the right. And we don't have any in this case, so that would be 0 of them. So in total, when we're adding the ones that are actually significant, then that would mean there is only 2 significant figures because the ones that are to the left are non-significant. Okay, so this is explained in rule number 3. Okay, rule number 4. Consider all zeros to the right to actually be significant. Okay, so all of the zeros that are to the right of those significant digits are also significant. So let's look at the example. They give you 49.300 kilograms. That's the value. Now we know that the non-zero digits, those are significant. So I have 3 of them. But then I have 2 zeros. And I know based on rule number 4 that any zeros that are to the right of significant figures, then that means that those are actually going to be significant as well. So it says, and blank zeros to the right of the non-zero digit. So I have 2 of those zeros. So when I add these up, that gives me a total of 5 significant figures for this value. And this is based on rule number 4.
Now practice what you learned with the following questions.
All right, let's now go over section 2, which is scientific notation and standard notation. First, let's start with going from standard notation to scientific notation. Now, there are 4 major steps. Step 1 is where you move the decimal point to the place where only one digit is on the left side of it. Now, for instance, let's say that the decimal point in this number would be moved between which 2 digits when converting to scientific notation? Well, we want to leave only one digit to the left of it. So that means that it would have to be moved all the way over here. So that would be between 2 and 3. Now, step 2 is write times 10 to the right of that value. So I now have the value of 2.30924343 times 10. Now, since the decimal point was moved to the left, in this case, we moved it to the left. So we're going to write it in. Based on step 3, it says that if it was moved to the left, there's going to be a positive sign that's going to be placed on the exponent. So the exponent of 10 will be positive. Now, since the decimal point was moved, let's see, 1, 2, 3, 4, 5 places to the left, the exponent based on step number 4 will now be a positive 5 on that 10. Okay, so when we are looking at the actual value for this, it would read as 2.3 times 10 positive 5. So that would be my actual value. Take a look at scientific notation to standard notation. So the first step is determine the number of places to move the decimal point based on the number expressed as the exponent. So when we are looking at this example in number 1, it's giving us this value. And if we look specifically at the exponent is a 4. It says the value consists of 4 exponent, thus the decimal point will be moved 4 places when converting to standard notation. Okay, step 2. Now I need to determine the direction in which that decimal is going to be moved based on the exponent's positive or negative value. So in this case, we had a positive exponent, which means on this step, on that step, it tells us that if it's positive, you're going to move the decimal to the right. If it's negative, you're going to move it to the left. So since it was positive, I'm going to move this decimal to the right. Now, step 3, move the decimal point in the appropriate direction and the number of spaces by filling empty decimal spaces with zeros. So in this case, I am going to move this decimal 4 times to the right. 1, 2, 3, 4, which ends up being between 7 and 3. Now the value itself is going to read with that new decimal place and by me removing the times 10 expression. So in other words, my value in standard notation is read as okay, so that would be my actual value, which would be 20,327.3.
Now practice what you learned with the following questions.
Okay, section 3, metric system and unit conversion. So before we start with the actual practice problems, I want you to make sure that you understand how to read this little chart. So in the middle, right here, this would be all of the base units. So it would be, for instance, meters, liters, seconds, and so forth. Now, anything to the left of it are going to be extremely small values, and that's why your exponents here have negative on them. And as you see, 10 to the negative 1 would be represented as 0.1. 10 to the negative 2 would be represented as 0.01, and so forth. Now, anything to the right of those base units of this middle section right here, anything to the right of it is going to be larger values. So that's why our exponents here are positive. So 10 to the 3 would be 1,000, 10 to the 6, and so forth. Those would be larger values. Okay, so now let's take a look at an example here using the following steps. So step 1 says convert the value into a fraction form. Now we can do this by simply dividing it by 1. And then we have to illustrate the units. It's really important that you always illustrate all of the units when you are converting values. Now, number 1 says that you are starting off with a value of 38 kilometers and you want to turn it into meters. Now, first thing, like step 1 says, I have to convert it into a fraction. So I can simply do this by saying 38 kilometers divided by 1. Step 2, I now need to multiply it with another fraction. Now this other fraction is going to be read as the following. The numerator, which is the number at the top, has to have the desired units. So again, let's write down what we have. We have 38 kilometers divided by 1. Now I'm going to multiply it with a new fraction. They're telling me that the numerator, which is the number on the top, has to have the desired units. Well, my desired units in this case are meters. So I'm going to write in meters at the top. The denominator, which is the number at the bottom, has to have the units that I want to eliminate. Okay, step 3. Determine the prefix of the numerator. Express the representing value of that prefix in the denominator. Now, number 3 says the numerator unit is, so in this case, when we're looking at the top value, it was meters, which represents what? Well, remember, meters is not a prefix. Meters is a base unit, meaning no prefix. So when we are writing it in, and it tells you in step 3, if there's no prefix, when we're writing it in the denominator, we would actually be writing it in as a 1. So once again, let's kind of write down everything that we know so far. We know that we have 38 kilometers divided by 1, and we have meters divided by kilometers. And now we know that because my numerator is meters and it has no prefix, it's a base unit, I'm going to write in a 1 in front of kilometers. Okay, step 4 now. So step 4, it says, determine the prefix of the denominator. Express the representing value of that prefix in the numerator. Okay, so now I'm going to say number 4, the denominator unit is, and I know that the denominator unit in this case is kilometers, and it is representing what? Well, if you don't remember what it's representing, you can kind of go back to the chart that we were looking at the beginning and look at kilo. And kilo represents 10 to the 3 or 1,000. I'm just going to represent it by 1,000. Now, when we are writing everything out again, let's review what we know. We know that it is 38 kilometers divided by 1 times meters over kilometers. We know that it is 1 kilometer. And now we know that because my denominator is kilometers and that it represents 1,000, I'm going to write in that value on the numerator value. So this would be now 1,000. Okay, step 5. Solve the equation and eliminate the appropriate units. Now, the initial unit is kilometers, which is the same as the denominator, allowing it to be eliminated, resulting in what units? Well, we're going to result in meters as my final units. When the following equation is solved, the value is converted into what? So once again, let's move all of our values over to that last step. So we have 38 kilometers over 1. We know it's 1,000 meters over 1 kilometer. And as we said, the kilometers can be crossed out. So in reality, all we're doing is we're multiplying 38 times 1,000, 38,000 meters.
Now practice what you learned with the following questions.
Okay, section 4, vectors and scalars. Let's first start by describing numbers that only have magnitude, and these are known as scalars. And these would be examples as like length, time, mass, etc. So let's look at this first example. Object A has a mass of 38 kilograms. Object B has a mass of 95 kilograms. Object C has a mass of 74 kilograms. Object blank has the greatest magnitude because it is the blank number. So in this case, when we're discussing magnitude, we're actually referring to this value. So in other words, which one, they're asking you, which one of these objects has a greater value, okay, a higher number. So higher number. And in this case, that would be object B. That's the one that has the greatest magnitude. So it would be object B. Okay, number 2. A dog travels 2 meters, rests for 2 seconds, then travels 8 meters, and finally 3 meters. The total distance traveled is blank. Thus, the magnitude is blank. So they're telling you that distance is being expressed with meters. And you know that 2 seconds then would be extra information that you do not need. So you can eliminate that. So in reality, all they're asking you is to add up those distance values. So we would have 2 meters plus 8 meters plus 3 meters, giving me a total of 13 meters. So the total distance traveled is 13 meters. Thus, the magnitude, remember magnitude is the value, would be 13. Now, they are not asking you in what direction did the dog go. Okay, they are simply wanting to know the magnitude. They are referring to the distance only. Okay, so that would be a form of a scalar. Now, if we want to involve direction, so now we would look at this other number. Numbers that have a magnitude and direction are known as vectors, such as velocity, acceleration, force, etc. So let's take a look at the first example that they give you. They say a dog travels from point C to D. So it's going from here to here. Okay. Then from D to A. All right. So then it goes from D all the way to A. Then from A to B. Then it goes here. Okay. Now it says, thus the dog traveled, they want to know the magnitude in meters to the, and then they want to know the direction from point C to D. So from point C to D, it traveled 2 meters, that was the magnitude, and the direction was to the right from point C to D. Then it went another magnitude in the direction to D to A. So D to A, it now traveled, what was the total distance here? Well, how would I know the total distance? Well, I would add up all of these. So this is 3 plus 3, that's 6, plus 2, that would give me 8. So it gave me a total magnitude of 8 meters. To the direction of, it's going in this direction, so that would be to the left. Then it had a magnitude and direction from A to B. So now it's going from A to B. So that was 3 meters. And it's going to the direction to the right. Okay. Now you need to keep in mind that when we're looking at direction, it's much easier for us to shorten the way that we're describing the direction. So often, instead of saying, writing out right, that it moved to the right, we often use either a positive or a negative sign. So when we are trying to illustrate something that moved to the right, we use a positive sign. When we're trying to illustrate something that moved to the left, we use a negative sign. Same thing goes for up and down. Up, we use a positive. Down, we use a negative. So, and that's exactly what is being described next. It says the magnitude is the number value, and the direction is illustrated with a positive sign if the object moved to the right, or a negative sign if the object moved to the left. Okay, so let's keep reading. Then it says, when all the changes in position are considered, what would you see here? So if I'm actually applying that positive and negative signs to these magnitudes to illustrate those vectors, then how would they look like when I'm adding or taking into account all of those changes in position? So the first one, which was going from C to D, it was moving to the right. So that would be okay, so it says when all the changes in position are considered. So now let's take into account that positive and negative sign with these magnitudes. So C to D, we said, was to the right, so it's going to be positive, and it was 2 meters, so it would be positive 2 meters. Then D to A was moving to the left, so that means it's going to be a negative, and it was 8 meters. Then A to B was to the right, and it moved 3 meters. So it would be positive 3 meters. Okay, so now what we need to do is we need to take into account all of these vectors and come up with what the sum would be of these vectors, which in this case would be the same thing as us looking at going from position C to position B. Because in reality, that's actually what we did. Okay, so you should know what is it that happened in the total change of position. You should know that you went to the left, in other words, and that you moved a total of 3 meters. So my value should actually be, I would already know that my value should be a negative because it moved to the left. That was the final position. And it was a total of 3 meters. But let's verify that both of these sides equal the same thing. So when we are adding up these changes in position, when we're adding up these values, notice how we have a negative and 2 positives. So let's first add up the 2 positives. That gives me positive 5 meters. And then I have negative 8 meters. So that gives me a total of negative 3 meters, which is exactly the answer that we came up with. Now, the result is the displacement of, so what would be the actual displacement here? Well, it would be negative 3 meters. Then they want to know with a magnitude of, so remember, magnitude is illustrated by the number. So the magnitude would be 3. And the direction to the what? So because it was negative, that means that it moved to the left. Okay, section 5, algebraic manipulation. So in this section, we're not going to be actually solving for numbers. In fact, we're going to be looking at only the variable, okay? No real numbers involved right now. We'll input the numbers later. I first need you to understand how to manipulate equations so that they could be equaling the specific variable that it is that you are searching for. So in this case, number 1, we are searching for variable t. So I want you to rearrange this equation so that it could equal t. Now, the first thing that you need to do is identify where is t in the equation and what's going on with it. So in this case, we have t being multiplied by a, and it is also being squared. Now, we'll get to the squared afterwards, but first, let's see how it looks like in this equation. So we said that it's being multiplied by a, but you need to keep in mind that there is also this fraction next to it. So you might not be able to visualize it as well because of the way that it's written out, but this equation can also be written out as at squared over 2. That means the same thing. So the first thing that I would do to get the t by itself is get rid of this 2. Well, because it's being divided, I should multiply by 2 on both sides. So that gives me 2y equals at squared. Now, to get t by itself, I need to get rid of the a. Well, a divided by a gets rid of it. Well, I need to do the same thing that I did on one side to the other. So now I'm left with 2y divided by a. So 2y divided by a equals t squared. Well, I want t by itself completely. So now I need to get rid of the squared. And the opposite of squared would be square root. Whatever I do on one side, I need to do to the other. So in reality, my equation would now be t equals square root 2y over a. And that would be my actual equation. So I want you to box that in. Get used to boxing it in. That way you know that that is your final answer. Okay, so now let's try out number 2. Number 2 is searching for V naught, or also known as V initial. So when we are looking at this equation, notice that that V initial is being multiplied by t. And then you also have the addition of 1/2 at squared. Well, I want V initial by itself. So the first thing that I want to get rid of is what is being added to it. So because all of this is together, I can simply subtract all of that together as a bulk as well. And I'm going to subtract it on both sides. So that would give me, so I'm subtracting it on both sides. So these would cross out, and that would give me x minus 1/2 at squared equals V initial times t. Now, I want to get rid of the t. I want to leave the V initial by itself. Well, because it's being multiplied, I need to divide on both sides. Okay, now I'm going to be left with V initial equals x minus 1/2 at squared over t. And that would be my answer. Okay, so now let's try out one more. In this one, number 3, you're solving for b. And I need you to get very used to how to manipulate this equation. Some of you might recognize it. This equation is the Pythagorean theorem. And you need to be very familiar with it on how to manipulate it because we're going to be using it a lot. So number 3, we are solving for b. Well, b is being added to a squared as well. So the first thing I want to get rid of is a squared. And because it's being added, I can simply subtract on both sides. So that leaves me with b squared equals c squared minus a squared. Well, I want to leave it as b by itself, no squared. So that means I need to do square root on both sides. So that leaves me with b equals square root c squared minus a squared. And that's my answer. Okay, last one. Number 4, I'm solving for x. So here we have a square root. I need to get rid of the square root. So you're simply just going backwards. Okay, so you would get rid of the square root by adding a squared on both sides. So that leaves me with v squared equals 2ax. Now, get rid of the 2a. And you could do it one by one, or you can just do it as a group because they're being multiplied. So I'm going to divide it on both sides. So that leaves me with v squared over 2a equals x. And that would be my value.
Now practice what you learned with the following questions.
Section 6, trigonometry. So in this section, I want you guys to make sure that you remember this key mnemonic device, which is SOHCAHTOA. Now, I know that you guys have probably heard this before in your math classes, and I really need you to make sure that you remember these, because that's how you're going to remember what the actual formulas for each sine, cosine, and tangent are. So sine, you have SO, which is opposite over hypotenuse. Cosine, which is ka, you have adjacent over hypotenuse. And then TOA, which is opposite over adjacent. And you need to remember that. It's going to be very helpful when we move on to the next units of physics. Now, when we get to the next parts, when we're talking about vector components, that is when we will discuss where you also use y over resultant, x over resultant, and y over x. And we'll discuss that in greater detail later on. But I wanted you guys to just kind of start remembering about that. Okay, so now let's take a look at the first problem that they give us. So the first problem says, solve for x. X, which is a side of the triangle. Notice how they're giving you the hypotenuse and you have the other side of the triangle. So in reality, you can solve for this using the a squared plus b squared equals c squared formula. Now you can use either the method that we talked about in the previous section, which was solving for the variable first and then inputting the actual values, or you can just input the values and solve for the missing variable. It's up to you, whatever makes it easier. So for instance, let's say that I have c, which is 30 squared, equals b squared, I don't know it, plus a squared, which is 18.88, and that's squared. 30 squared would be 900, and I just kind of bring everything else down. Now let me solve for 18.88 squared, and that gives me 356.45 plus b squared equals 900. Well, now I need to get rid of the 356.45, move it to the other side so that b can be by itself. So I need to subtract it on both sides. And when I do that, that gives me 543.54. Okay, now I need to do the square root of that value. Okay, so the square root of 543.54 would be 23. So I need to square root everything. So that would be b equals 23.3 meters. And that would be my answer. Number 2 states, solve for x. So they're giving me this unknown. I know my hypotenuse, but I don't know the y, which is the other side of the triangle. But I do have a angle, okay? And if you remember from what we talked about with SOHCAHTOA, okay, you need to remember which ones are the opposite, adjacent, and hypotenuse. So the hypotenuse we know is this one, the longer side, okay?
Opposite means that it's opposite to the angle.
Adjacent means that it's the side that is next to the angle. So this would be adjacent. And because I am solving for x, which is labeled as adjacent, then that means that thinking of SOHCAHTOA, that means that I would be using this one right here. Okay, because that's the one that's involving adjacent and hypotenuse. So that would be cosine theta equals adjacent over hypotenuse. Well, I know that my theta in this case is this angle, so that's cosine 35 equals, my adjacent would be the unknown x, the hypotenuse would be 10. Okay, so now I solve for x. So the first thing that you need to do, using your calculator, make sure that you do have it in degree mode. Okay, you would first figure out what is cosine 35. So the cosine of 35 in degrees on the calculator would give you a value of 0.81. So I'm going to write it in as 0.81 equals x over 10. Now I need to get rid of the 10. So I'm going to multiply by 10 on both sides. That gives me, that side of the triangle would be x equals 8.1 meters. And that would be my answer.
Now practice what you learned with the following questions. This concludes our summer assignment video. Make sure that you study, and that's it. Have a great one.